All right, guys, we're taking a look at our energy review here. So just off of our notes that we've taken, or just taking a look at, we want to identify the following statements, okay, as whether or not they have, or we're talking about kinetic energy, potential energy, or both. If an object is at rest, it certainly does not have this energy. Not have this energy. Well, it needs to be moving in order for it to have kinetic energy. So if it's at rest, it definitely doesn't have Ke. So everyone should have Ke there. How many people got that one right? All right, that's what I like to see. Number two, this is going to depend on the mass and height of the object. So I had a couple people put both before because they read the mass and yes, potential energy, all right, and kinetic energy both have m in the equation. All right, 1/2 mv squared, and our gravitational potential energy, they both have mass, but this one is saying, all right, mass and height, where kinetic energy does not have height, so it has to be just Pe. Energy an object possesses due to its motion, it's got to be kinetic. All right, so V, velocity, speed, anything that's given to you in the problem like that, that will be your V in the problem, your motion. So if you have any of that, that is what we're talking about. We're talking about kinetic. Both of which are abbreviated in the unit joule, capital J. Also, what other thing uses the term joule as its unit? Good. All right. Work also has joule as the unit. All right. An object's energy stored in an object due to its position or height, HPE. This amount depends upon the arbitrarily assigned zero level. So if an object is on the ground, okay, and that's zero, the potential energy is zero. If we raise it up and it's sitting on a table, and we're saying relative to the table, it has zero, but relative to the ground, it would have a certain amount, depending upon whatever the mass and height is. Okay, so yes, its potential here depends on mass and speed, kinetic. If an object is at rest on the ground, zero height, it certainly does not possess this form of energy. Well, if it's at rest, V is zero, the whole thing is zero. And if the height is zero, this thing is zero. So both of them. So here they're telling you that a car is moving with 0.40 joules worth of energy. Speed is doubled. What is the new kinetic energy? So what you guys have to do for this is, or what I've kind of taught, will be writing out the equation. Since 1/2 is always there, we're not even going to bother bringing it down because it's kind of just in the equation. All right, something that's not going to be changing. What can possibly change are your mass and speed. All right, mass and velocity. So we're going to basically say, okay, mass you're 1, velocity you're 1, but if it's squared, it's got to be squared. Now they told us that if the speed is doubled, what is going to happen to the kinetic energy? Well, V is this one. So we're going to change that to a 2 because they said doubled. If they said if it was tripled, we'd make this a 3. They didn't tell us anything about the mass, so it stays a 1. 2 squared is 4. 4 times 1 is 4. So you would have 4 times the original kinetic energy. In the problem, they said that the original kinetic energy was 0.40 joules. So 4 times 0.40 is going to equal 1.6 joules. And that is how you do it. All right. They said a young boy's glider soaring through the air has 0.80 joules of potential energy. If its speed is doubled and its height is doubled, speed is doubled, what is the new potential energy? So I had a couple people saying, what do I do with this? Well, speed is doubled, that would affect the kinetic energy, but they didn't ask us about that, so we don't actually need that. So the height is what's going to be important here. Again, potential energy, mass times gravity times height. Make the mass a 1, make gravity a 1, make height a 1. And only change, all right, the variable that they tell you or talking to you about. In this case, height is the one that's doubled. So this 1 underneath the h, we make it a 2. Gravity didn't change, mass didn't change. So 1 times 1 times 2 is 2 times the original potential energy. If the original potential energy was 0.8, you're going to do 2 times that. 2 times 0.8 is going to give us 1.6 joules worth of energy. Which would always be true of an object possessing kinetic energy of 0 joules. Well, kinetic energy, the object has to be at rest. All right, definitely. And if it's at rest on the ground level, also fine. If it was at rest on a table above ground, that's fine. All right, so on the ground, it can't say if it's just on the ground, because if it's rolling on the ground, it's moving. So that's why we can't just say that. It has to be very specific. Always be true of an object possessing potential energy of 0 joules. In this case, being on the ground, definitely, or if it's necessarily just moving on the ground, it could still have a potential energy of 0 based off of that one simulation we did with the roller coaster. If the roller coaster is the bottom of that track, okay, potential energy was 0. As long as there's no, increase or decrease in height, C is valid. A is going to always be correct, but C would be really dependent upon if it's a flat surface, right? Okay, so here are our problems here. Calculate the kinetic energy of a 5.2 kilogram object moving at this such and such a speed. So you do 1/2 of m, 5.2, times 2.4, which is our speed, because that's meters per second, squared. All right, only square velocity, then multiply by the mass, and then I would divide by 2, and this kicks out an answer of 14.976 joules. We're looking for kinetic energy. For the potential energy here, that was for kinetic, this is for potential. You have mass of this, mass 5.2. We're using 10 for gravity instead of the 9.8, just because sometimes it gives us better, nicer looking numbers. And then a height of 5.8 meters above the ground, and you should get an answer here of 301.6 joules. And then this last one, 2 times the kinetic energy. So 2 times, let me erase that. So we already have the equation written. This is just rearranging the kinetic energy equation. And you have to do 2 times 26.1 divided by the mass of 5.2, and then you're going to square root that answer underneath. So typing that into your calculator, we're going to throw out an answer here of 3.168. Not joules. What is the unit for velocity? Help me out. Meters per second. Good. The total mechanical energy of an object, ME, is equal to kinetic and potential, or potential plus kinetic. Either way, if you write it, it's good. So we're looking at letter D. Here, an object moves in such a manner to conserve its total mechanical energy. Then, yes, letter D. And then the last one, it just asks you to determine the kinetic or the total mechanical energy at each of these positions. You're just going to add them. And when you do, you're going to get 10,000, 9,000, 100,000, and 80,000. So those would be your energies. All right, and they should all have joules. All right, taking a look at this, it asks you to draw in the triangle to calculate power. So it tells you that power is work divided by time. So that means it has to have a certain position in my triangle. Power is work divided by time. So, but remember that the unit for work is the joule, the unit for time, seconds, unit for power is watts. Triangle to calculate work. Up here it tells me that work is force times distance. So W is F times D. D will be in meters. Work is in joules. Force is in newtons. There is another equation that I would venture to say. All right, we can add, we'll just add it over here, is that power will equal, right, because power is work, W, and if work is force times distance, you can have force times distance, and power, it would be work over time. All right, and we can rearrange that as power times time is equal to F over D. So you can use that to help solve for any of those four variables, which you will need in one of the problems. Okay, the first one, all right, should be fine. The second one, all right, number 4, should be fine. All right, you guys should be okay with those. For number 5, how many meters? Joules, that's work. To raise a block weighing this much, that's a newton. So you're looking for distance, right? Because they're asking for how many meters. What power are we doing with 5 joules of work in 5 seconds? You can find power with watts. All right, 70 or 7 and 8 you should be fine with as well. But for number 9, if it takes 40 meters to move a box, how long will it take a 40-watt motor, which is P, to move this thing 5 meters, and this is your force. They want T. So in this equation that we wrote down here, power times time is force times distance. Power times time will equal force times distance. You have everything except for what? T. So how do I get T by itself? I would have to divide both sides by power. So T will equal force times distance over power. All right? That's going to be the equation that you need to solve. 10 is just the potential energy equation. So for 10, you just need the potential energy equation. The potential energy equation is, right, from your notes, we have that, the triangle. Potential energy is equal to mass times gravity times height. Potential energy is in joules. Mass, kilograms. Gravity, we're using 10 meters per second squared. So we just need the 10. And the height will be in meters. Number 11, they're like, all right, how many meters would it take a 100 kilogram mass to be lifted to have this much energy? Okay, so we have our J for PE. We have KE for M. They want us to find height in meters, and G is 10. So if I covered up H, it's PE divided by mass times gravity. So that would be the equation to use. If we're looking for H, the potential energy divided by mass times gravity. So make sure you guys have that jotted down. Vice versa, you have joules of energy and you have height. They want to know mass. So if I cover up m, what does m equal? Correct. It would equal potential energy divided by gravity times height. Okay, find the kinetic energy of the ball. The kinetic energy equation is 1/2 mv squared. You're only squaring velocity. They want you to rearrange this to solve for m. So to get m by itself, you have to double both sides. You got to multiply both sides by 2. So it'd be 2ke is equal to mv squared. And then to get rid of v squared, you got to divide both sides by that. And so you would be left with 2ke divided by v squared. Make sure you put that v squared in parentheses in your calculator just so we don't get any mishaps. And then this last one, that's m, okay, and that's ke. They want velocity. So velocity, the equation for that is 2 times the kinetic energy divided by the mass, and you have to then square root it. All right, so you're going to do 2 times the kinetic energy, all right, which is this number here. If you don't know how to do that into your calculator, that is going to be 1.83. All right, e to the 14th. To get e, you're going to hit this button here, the double E, times 14. Okay, it throws it into your calculator. It's a very, very large number. Then you got to multiply that by 2. And then you got to divide that by the mass of 52.8341. And then we have to square root that whole answer. So second, square root, second answer. And we should be left with a value here of 26,319.85. And that would be our velocity, meters per second. All right, so you guys finish that up, do the work, show the work, get your answers, and then throw your answers to those also up here with the correct units. Yes, Mika.